Let me add on with the red color. Okay, so this question, given
It's
this,
9 o'clock.
okay, given this displacement function, then they ask you to sketch the graph from 0 to 6. Okay, you use the GeoGebra app, right? So definitely your graph has to be correct if you key in correctly, right? And by the way, they want 0 to 6, and then you show me the rest. No need. Okay, they want 0 to 6, that means strictly stop at 0 and 6. Don't show me anything beyond. No. Okay, so when you use the GeoGebra app, you also need to think. And when you sketch on the spot, you also need to follow strictly. Okay, they want 0 to 6. You don't show beyond 0.
So I
You
wrote
don't.
the table there. So you use that to draw, right?
You should start from 0. 0 to 6.
But 0 is 0.
0 then 0 is 0 lah. Start the origin lah. So what?
Okay.
Yeah. Okay. Yep. So you need to use this table to do. Okay. So but never mind. So I just want to let you know, when you show, please, like don't. What you show me here is like, okay lah, Jojoba, give me this. Okay, I just give it to you. Okay. Yeah. So show that you read the question and then you answer the question correctly, even though you use software. Okay. Never mind. Next. Then they say use the graph the time when the particle turns the opposite. Yes. So that's why I say it stops and turns when the particle will stop and turn is when the v equals to 0. So I want to find out when v equals to 0, what's my time, right? So that's why I say you must get the s prime, which is the gradient, and which is the v, right? That's how it flow, right? Like you have a displacement, then you differentiate once with the t, then you get your v. Another differentiation, you get the acceleration, right? Okay, so from this graph, they say use the graph, right? That means you cannot use math graph. So if given this graph, where's my v equals to 0? Can you see that v is the gradient?
Yeah, and gradient.
So it's when gradient equals to 0 lor. So if you look at your curve, so basically from 0 to 6, so let me just draw the curve from 0 to 6. Yeah, somewhere here, 0 to 6. So from 0 to 6, the curve here, which point the gradient is 0?
The turning point.
Here, right? Right?
Mm.
That's why I come down and ask myself, the t equals to 2. That's why I say v is the gradient equals to 0 at time equals to 2. Therefore, the first answer is t equals to 2. You can verify. How to verify?
You sub in the t.
You sub in t equals to 0 to where?
S.
Very good. You sub in, what do you get?
Must get 0. Isn't S the displacement?
Yeah. So, what do you get?
Oh, 24 minus 12.
12, right?
Yeah.
So, when t equals to 2, s equals to 12. How do I know whether it turn or no turn? I write down t equals to 0. What's my s? 0, right? Okay, good. So, done for the first question. Next, the distance traveled by the particle in the first 6 seconds. So, t equals to 0, s equals to 0. And when it stops and turns, t equals to 2, s equals to 12, right? So, therefore, do I need to test for other time? Besides t equals to 0, besides t equals to 2?
Maybe
Do I have to test for t equals to 4 or t equals to 3?
Sure. You can.
Then like that, why not t equals to 3 by 1? Why not t equals to 3 by 1, 1, 1, 1, 1? So that means what are the critical time you need to test for to get the distance?
So you need to draw. So t equals 0, then t equals 2, then after that t equals 6.
Why not t equals to 4 then? Why you jump from t equals to 2 to t equals to 6?
Because we know it turns the opposite direction at t equals to 2.
Then why you don't care about the t equals to 3? Why you don't care about t equals to 4? I agree. Yeah. I agree. Like t equals to 2 is a critical point
But
in
then
time.
the graph,
Then what about t equals to 3? What about t equals to 4?
you can see the graph, it doesn't show like.
No. Nothing to do with this. Why not t equals to 1? To find distance of a particle, you just need to know how many times it stops.
Yeah.
Because only when it stops, it turns direction. Okay? If it doesn't stop, you continue the direction lah. So therefore, t equals to 0, s equal to 0, right? So that means you start from here. If you go, then t equals to 2 is here, right? S equals to 12, right? So that means you will go to here. And then at t equals to 2, it will stop. Right? Because instantaneous rest. Then there is a chance for it to turn. There is a chance doesn't mean it will turn. Right? How do you verify whether it turn or not? Do you need to test for t equals to 3? No. You just test for t equals to 6. T equals to 6. S equals to. Can you help me out?
Negative 36.
From the origin, huh? So from here, I know that it will turn. Why? Because my t equals to 6 is negative 36. So I know that here it will turn. Don't you test for t equals to 3? No, it doesn't stop. Don't stop. Continue. Right? Don't you test for t equals to 1? No. Because my t equals to 1 never stop. So we only go that one direction. So that's why when you find distance of a particle travel, you need to find out the critical time. The critical time. So if they ask from the first 6 seconds, right, you always test for the t equals to 0, t equals to 6. And then in between, which one is the critical time?
T equals 2.
In this case, it's t equals to 2. What about other question? So it's t equals to.
Whenever it stops.
Yes. Okay, so t equals to that when the v is equal to 0. That's what you need to test when you find distance. So that's how you get the distance. So start here, go here, then back to
So 12.
here.
12 plus 36.
12, 36. 12, 36.
Yeah.
Yeah, so it's 24 plus 36. So it's 36. 60. Okay, so that's how you figure out this. Or if you don't want to do that, what you do? Area under the curve. Okay, but of course area under the curve is a bit hard here. This is the area under the curve from 0 to 4. Then you need to find the 4 to 6. So you need to flip. Right? So I